Hi everyone. So today I'm going to get us started on using bonk, which is a great name for an object, which I think you'll probably use as the basis for your final projects. So we played around a little bit with bonk early in the semester. I kind of introduced it very briefly in one class, and then was like, hey, this is cool, and then put it aside. And I don't know if that was the best idea, but anyway, I apologize for that. It's a super interesting object, and basically what bonk does is it listens out for transient sounds, so things that make a quick, sharp sound and then stop very shortly. So almost anything percussive, for example, snare drums or claps or snaps or kind of sounds, it does very well with. And it comes now as part of the basic pure data package, so it's quite useful. So what we're going to do, I showed very briefly in the last video I made a very simple synthesizer that played little like boom sounds every time there was a transient detected in bonk. So I'm just going to show how I made that patch, and it'll kind of hopefully get you started on everything. So I'm just starting with the blank window here, and I'm going to start by talking through the building of a very, very simple synthesizer. So it's not even really a synthesizer, it's just one oscillator, but I'm putting a volume envelope on it. So that means it is not just constantly playing, it means that it will make I will be able to control how long it takes to start and how long it takes to go away. So it can either be boom, or it can be boom, or it can be whoa, and so on and so forth. So the first thing that I always start with making is the oscillator object OSC tilde. Remember, the tilde means that we're dealing with signal, so that's going to generate a signal, and I'm going to give it an argument just to start so it can start making noise immediately. Remember, at this point, as soon as you start wanting to make noise, which will be in just a couple steps, just make sure your audio settings are switched to your sound card, and make sure that you have DSP clicked on the little checkbox in your in the PD window. Now, if I were theoretically to just send this out, the sound card, which is the DAC object, so that's any audio output that I've set. If I just connect that, I'll make a sound. So it's a very loud, obnoxious, continuous sound. So that's kind of what you can imagine is coming out of this oscillator. What we want to do to control that is use the multiplication tilde object. And this is essentially a volume controller, but we're going to make two of these. We're going to make one that doesn't have anything, and we're going to make another one that goes times 0.6. Now this is just some arbitrary number I picked, but what this second one is doing is controlling the overall volume, so it's bringing everything down to 60%. Now if you imagine this sine wave, when it's coming out of our oscillator, is going all the way to the maximum it can, and then all the way down to the minimum it can, and back up again. That means the volume it's creating is as loud as the sound card can make it without distorting digitally. So that's really loud, and it's really hard to control, and it's not a very useful thing. So you need to kind of bring that maximum and minimum down, and you do that simply by multiplying the sine wave, or whatever sound wave is coming out, by something less than 1. So I usually use 0.6. It's a nice kind of middle ground. Now I'm going to connect all of these things, left inlet, outlet to left inlet, left outlet to left inlet, and then this I'm going to connect to both, because if you remember on DAC tilde, the two inlets are left and right, generally speaking. Now there's no sound. That's because in this first one, we're not multiplying it by anything, and it's defaulting to 0. So we're right now multiplying by 0, and then multiplying 0 by 0.6, so it's still 0. So we've got no sine wave coming out. So what we want to do is put some numbers into this right inlet in our multiplication tilde object, and that will control the volume in our case, we're going to control it in a nice dynamic way. So we're going to start with by using the line tilde object. What line does is it creates ramps. So when you send it some numbers, as we will in a second, it will create a nice ramp going from, in our case, 0 to 1 over the course of some number of milliseconds. And it's doing that because of the tilde. You know that it's doing that at signal rate, so many calculations per second. And so it's very accurate. It will sound good. It will do everything we need. So, for example, if we make a message box, remember that's Command or Control 2 to make a message, and remember that messages have the funny little cutout to the side. The types of messages line takes, the line tilde object takes, is 2 numbers. So the first number is what's our target. So we're going to say we're going to go to 1 because we want to go to maximum volume. And then the second number, 1 space, is in milliseconds, and it's how long we're going to take to get to that target number. So just for illustration's sake, we'll put 500. Now I've just locked the patch, and when I click on this, it will go from 0, where it is now, up to 1 over 500 milliseconds, and you'll hear the result. So it fades in nicely. Let's do the same thing. I made a second message that goes down to 0 in 500. So that's nice. We can bring this way down to 50, for example, and you'll hear the difference. With sine waves, it can be quite subtle. Let's make it down to 5. Right, so now you hear it as a dum, dum. But it's waiting for me to click those message boxes. Now, I'm just going to put a comment here to say message boxes to remind you that that's what those are. Those are our message boxes, but what we're going to do now is put variable numbers in here. So instead of just fixed 5 and 500, we're going to make those changeable. Now, in pure data, variables use these dollar symbols. So we'll say $1 and $0 And ahead of that, we're going to use the I object. Now what I does is it can do several things, but what it can do in our case is store an integer. And that means it's holding on to that integer and waiting for a bang. When it receives the bang, then that number will be sent out. Now, if I, for example, change this number, nothing will happen, nothing will happen, nothing will happen. And then when I send a bang, switches it off. So the I object is a really useful thing when you're wanting to control and change values, but not have them screw everything up while you're changing them. So if we imagine, let's make this a bit bigger so you can see it better. There you go. So we've got our bang that comes in, and that we can use as the trigger for playing our sounds. Now the first thing I'm going to do is set some values for this that are defaults, because right now if I open this up, this will as a new patch, these will both default to 0, and I won't hear any sound. So I'm going to make a load bang object. What load bang does is when I first open the patch, it sends a bang. I'm going to make a message box, and this will just be my starting values. So if we click our message boxes, that sets this to 10, this to 150, this we can call, in music terminology terms, our attack here. And this is sort of like a release. It's not quite the same, but if you imagine the release is how long it takes from something to go down to 0, and the attack is how long it takes something to start. So a very short attack is a very low number, and a very long attack is a high number, and the same thing for release. Okay, so those are our attack and release. Now, when I press this, it will bring me up to 1, but we're still not triggering anything here to actually trigger the release. So this starts to get slightly funny, because what you really want is you don't want this release to start until the attack is finished. So we use a really simple, it's kind of like surprisingly stupidly simple way to do this. And that's by using a delay object. Delay will just take a bang and it'll wait for a certain amount of time before sending that bang out. So if we take our starting point bang, send it into delay, and what we want is for the value of delay here to be the same as the attack, right? Because that means it will wait, in our case now, 10 milliseconds before sending this release. If we bring this up to 200, we want it to wait 200 milliseconds so that it can go all the way to 1 before it releases. So very simply, we'll just tap into this number, the outlet of this number, and send it over to the right inlet of delay. Now make sure you're using the correct inlets and outlets. So the bang goes into the left of delay, and the value, the number of milliseconds you're wanting it to delay, goes into your right. Now that's it, really. If we bring this back down, you can hear it has a nice, fairly short attack, but we can bring that way down. And let's bring our release up to make it sound a little softer. Boom. Bring it even further up than that. Let's bring it up to almost a second. So that's nice and smooth. Sounds pretty nice. Okay, cool. So there's our play note. There we go. So that's a pretty decent, little, extremely simple, but surprisingly nice sounding synth. We have a little bit of control over the attack and release, which is nice, and what we don't have, and it's nicely controlled volumes and all that. Now you can always control the overall volume by putting a number in here, but at the moment it's not really bothering me. Now, of course, we're just playing a single pitch so far, and that's not super exciting, I guess. So what we will do next is start having some control over the pitch. Now, we can obviously just stick a number in here, and that will change the pitch. But what I'd like to do instead is have there be a sequence that we can play of, say, 16 or 24 or 8 or whatever number of notes. Now, the first thing we want to do is make a really simple array. So I'm going to make an array here. So it's Shift Command A, and I'm going to put a size of 16. And I'm going to call it pitch sequence. Now, pure data is a little bit weird, because now I'm going to then right-click, go to Properties, and go under here, and where I have my Y range, I'm going to set this to a slightly weird set of ranges. I'm going to go from 100 down to 32. Okay, that's because I'm going to be triggering MIDI notes, and MIDI notes, that's a nice range of MIDI notes. You can see it redraws my things down there, but I'm just going to draw it in there. There we go. So there's my pitch sequence. Now I'm going to want to read this pitch sequence, and then I'm going to want to convert that to frequency and send it to my synthesizer. Okay, so the first thing we'll do is make a little counter. What the counter can do is read through this pitch sequence. So we're actually going to use, well, let's start by making a fresh one. So bang, a message box with the number 1, an object, the plus object, connect those, a number box, connect the output of the number box to the other inlet of plus, and we've got our counter. Now we want a modulo object because that's going up to 24. Set our modulo to the same size as the array, in our case 16. And now if I put a number there, you'll see it goes between 0 and 15, which is exactly what we want. Okay, so that's kind of optional. We don't really need to have that number box there. Gets in the way. Then we'll use the tab read object, which is what we'll use to, well, to read our table. Move everything off to the side here. And if we look at the numbers that come out here, you can see they are changing alongside. And that is corresponding to these numbers in here. So whenever it goes 0, 1, 2, 3, 4, 5, it's giving me the values of the of that graph as you see it there. So, whoops, there we go. So that's reading our pitch sequence, very nice. And the final thing we need to do is convert that to frequency. So we use the M to F object. That number we can put straight into our thing. That's because 56.28 is not really a good, well, it isn't a very useful frequency. It'd be extremely low, but it's a very nice MIDI note. So that corresponds to like a D or something. I don't know what it is. I don't know, what is that? It's like an A. I think it's an A, roughly, on a keyboard, like a middle A. And that then gets converted to the appropriate frequency to be played by a sine wave for that note. So we're still not hearing anything, but that can be very easily simplified by using the same plain note object, bang, that we used previously. I'll get rid of this bang. So that's cycling now through that pitch sequence. If we want to see where we are in the pitch sequence, it's pretty straightforward to do. We want to take the number that's coming out of here, and we can just show it on a little graph. So I'll use the horizontal slider, but I'll set the properties to be from 0 to 15, the size of our array. And then I'll also set the properties to be the same width as my array, which defaults to 195. Out of here, move it over here, and now when I press bang, you see where we are. Boom, boom, so you can see it, and then it's going to pop up for 2 notes, and then back down, down, a little lower, a little higher, a little lower, lower, back up, and then it's going to go 4 notes in rising sequence. Those first 4 notes sort of sound like the number not available thing, doesn't it? Right, so there's our... If we want to change any of the settings, we can bring our release down. Okay, cool. So that's nice. Now, using bonk. So the bonk object, bonk tilde, what it does is it listens to the audio input. So what the first thing you can always do is make an audio input. Now, ADC tilde is the audio input, analog to digital converter. It's the opposite of DAC, right? So if you imagine this is your microphone, there's usually 2 channels for your microphone. In most cases, I would imagine most of you will just use one, like I'm doing now. So you take the microphone input and you run it into bonk. We can just keep it there, nice and simple. You can put a volume control here if you want to control how much sound is going into bonk. In our case, I don't think we really need it. And the main control that I would suggest you learn to use, the main parameter, is called min-vel, and that's like stands vaguely, I think, for minimum velocity. And it's essentially like kind of like the threshold. It's basically like setting at what volume do you want bonk to trigger a sound, right? Do you want bonk to send a trigger, right? So at what volume of input? So if it's 80, it needs a quite loud hit for bonk to listen and send out a bang. If it's 10, it will listen to lots of things. But what you really want is some nice fine-grained control over that. So let's make a variable version, min-vel $1. And then I'm going to make a horizontal slider here. And this by default goes from 0 to 127. And you know what? That's actually fine. That's kind of not a terrible set of ranges. So let's just do that. And let's go to my properties and put a label on it, say threshold, to make it easier for me. And just to show you, you can see that right now, because my threshold is super low, bonk is sending out loads of stuff. As I bring this threshold up, those numbers of bangs will start to, initially they'll just, now you can just see it when it's quite low. There you go, you see it flashing just when I talk, which is cool. But if you make it even higher, it won't even flash when I talk. But if I clap, you see it flash. So that's kind of what we're after, right? We're after a threshold somewhere around here. This is probably at around 70 or something. And that will listen to quite loud sounds, ignore lower sounds. But it won't be too hard where you have to smack your hands super hard. Now, a very useful thing is to make a switch, right? To just turn it all off. And the switch object in Pure Data is called spigot. So what we'll do is we'll send the output of bonk into a spigot, and we'll put a toggle onto spigot. And let's label this bonk on off. Right, and spigot, confusingly, you put the toggle into the right inlet of spigot. And let's get the bang out from there. Now when I turn this on, as soon as I clap, you'll start hearing the sound. So it's really responsive. You can tell how quick it's happening. It's not loud enough for my snaps, but it's loud enough for claps. If you do it right, it should be really quick. Let's make it a little quieter so I can snap. Ooh, that's a little too quiet. That's a little too sensitive. If you bring this threshold down low enough, like you could see it flashing before, it'll every time there's a peak in my words that I speak, it'll start flashing, which is quite a nice effect actually. Because now there's also something happening here where that's why it's nice to have the toggle. So I have my microphone right here, and I have big speakers right here playing the sound out. Now I believe that my microphone is actually hearing what's coming out of the speakers, and it's creating a bit of a feedback loop. So if I bring down the volume of my speakers, I can actually bring this threshold down much further. And now, yeah, you can see it's much more responsive. It's stopping every time I stop talking. It's stopping. That's pretty great. And we can adjust our pitch sequence so that if you do it right, it actually kind of sounds like I'm talking. Let's make the release louder. There we go. How does that sound? so that's using bonk to read through a pitch sequence. Now, how long have I been going for? Some time? 24 minutes. Okay, I'm going to show a couple very quick little tricks to make this all look a bit cleaner. So the first thing is that if you right-click on any like clickable object, so for example this slider here, if I right-click on it and go to properties, you'll see that there's oh, I'm not sure if you're actually seeing this now that I think about it. Oh, you're totally not. Okay. Let me switch over to a screen grab so that you can actually see that. Okay, you should be able to see this now, I think. If you look at my slider properties, you will see that there's a send symbol and a receive symbol. Now, if you put a receive symbol on this and you call it something useful, so what's this slider? This slider is the current location, and I usually say receive. And I click OK. Then I can delete this and make a send object that's called current location receive, coming out of here. That means I don't actually need to have this connected to anything. And you'll still see it move across. It's much cleaner, right? So similarly, let's go to play note. And in this case, let's give it a send symbol. And let's call it play note. And while we're at it, let's give this a label, which is a cleaner way. So I can get rid of this comment. And now I can get rid of this, and I'll replace it with a send note. So I can send that there. And I can get rid of it here. I can put it back through here. And I can even get rid of it here. Why not? Okay, now that is totally not working. Why is it not working? Oh, because it's called play note, not send note. Okay, interesting, right? Now I can also give it a receive, play note receive, and then that means coming out of bonk. Okay, cool, right? So now we're starting to really get a much cleaner set of objects over here. Similarly, let's do the same with bonk on off. So let's call it bonk on off. Delete that. Receive bonk on off. Okay, that means we can move this over here. Pretty handy. And this one here, we can call it send symbol threshold. Receive threshold. Make that a little bit bigger. There we go. This might be better as a vertical slider, but hey. And we could do the same thing for attack and release, right? I mean, why not, right? So let's, in our attack, let's say receive symbol, attack, receive, and release, receive. Cool. Now, we'll have to do a couple funny things there, but let's get rid of this, and instead let's make 2 vertical sliders. One of them attack maybe output range of 0 to 100, and release maybe 0 to 1000. And we'll say we'll send, release, receive, which is a little confusing. And send, attack. Now when I change that, it'll change our attack number over here, release over here. Now the last thing we just need to do is for when we start up the patch, that way it will start up nicely. Okay, so all of that's pretty nice. We've got just this tiny handful of objects where we used to have loads of things. And finally, what we can do, if you like, is just take all of this extra stuff that we don't actually need to look at anymore. We can cut it, make an object called PD guts, which makes a new little window, and paste it all in there. We never have to look at it again. And that can be our patch. Now this where these things are is kind of annoying me. So let's say y offset, I don't know, 27. Will that be better? Yeah. Okay. So x offset 0, y offset 30. Let's say. There we go. That's a bit better. X offset 0, y offset 32 maybe. Slightly more. 35. There we go. Okay. So there's our patch. We can either play it by clicking it. Quite a boring sequence. Or it looks like bonk is on. Oop. What's up? Oh, that's good. Something's not working. What's not working? Oh. What am I doing wrong here? Send play note. Receive and it plays note. Okay. Bonk on. I just need to re-click bottom on and off because I pasted everything previously. There we go. Okay, cool. So there's our patch. The one last final thing I'll show you is a fun little extra thing I often do. If you make a message object anywhere in your patch, a message object that starts with a semicolon, you can then write the phrase PD space DSP space 1, put a load bang into that, and that'll automatically turn on your little DSP thing. So if I unclick it, click it here, you see it turns on my audio. So that's relying on the idea that you have the correct audio settings set up, but it's a handy thing that works most of the time. Okay, that's my tutorial. Let me know if you have any questions. Good luck. Make it for yourself. Maybe I'll put this patch up somewhere. I don't know. We'll see. Talk to you soon.